seemed like things impacted it randomly, how the performance of it was.
Well, I guess I will find out soon enough because mine is going to arrive on Wednesday, so I have something to talk about on Thursday about that technology, whether it's reliable or not. Because I have read a lot of mixed reviews on that. But wireless is the same thing too. If you have wireless, you can have dead spots in your house. For some reason, one room just won't get it, right? I mean, so I think all of this technology is still kind of. You don't always get the claimed bandwidth. The only way to get like high bandwidth is just to bite the bullet and wire your entire house with Cat 6 cables and a good good switch, a gigabit switch. Then you have the actual bandwidth. Yep. Go ahead. You're next. Yep.
As compared to the Wi-Fi, I know that it's actually, at least in my house and in my experience, better. I've had it in a couple different houses.
Okay.
It's not as good as hard wiring, obviously, but it works much better than Wi-Fi.
Mm-hmm. Yep, go ahead.
A lot of newer houses use like a metal mesh, kind of like fencing in the insulation.
Uh-huh.
And that disrupts radio signal.
So you kind of have your own Faraday cage. Yeah. That's funny because it's unintentional, but somehow it just ends up with the effect of a Faraday cage. So that means in older houses where they do not have that type of building material, it works a little bit better. Yep. Yep. Go ahead.
Yeah, I was going to ask. When Wi-Fi first came out, it came out with .11a, B, C. Now we're on N. It's been that way for a couple of years. Are they coming out something newer, better?
Yeah, there's a new standard after N. I don't remember what it is. Does anyone know what is the current standard?
It's A something. It has A and then another letter.
Okay.
I don't remember what it is.
Yeah, I think you're right. I cannot remember what it is, but they always claim a bandwidth, that is kind of insanely high. But then what you can actually get out of your router depends on a lot of factors.
I think it's actually AC.
AC? Okay. So it's 802.11 AC?
Something like that.
Okay. So that's kind of interesting, something that I worked on, over the weekend. I also found out, since we talked about operating systems, this is kind of like a little tag-on stuff on top of operating systems. Okay. So the question now is, how do you differentiate different versions of Windows? Why would you pay more for Windows 8 Professional? What does it buy you?
More features.
More features, all right. What kind of feature?
I don't know what they would have. I just know they would have more stuff.
Well, I was teaching this networking class, and I found out that with Windows 7, at least, I think Windows 8 applies too. With the Home Edition, it cannot join a domain. In other words, if you want to set up, a household where your profile is quote unquote roaming, in other words, it's not tied into a particular computer, you cannot do it with the Home Edition of Windows. You have to do it with, the professional or, an upgraded version of Windows, which I think is kind of artificial. That's completely artificial from the pricing and, just Microsoft trying to squeeze a little more money out of the licensing. So I find that kind of disturbing. All right. So are there any questions from before the break? Nothing? Cannot remember at all what we talked about right before the break? Scratch. Yep.
Were our test scores posted online?
They're already online.
And are they in the Moodle?
Yes.
Okay, I didn't.
So you go to Moodle, go to grades, and you should see
When
your
did you
exam.
post them on there? Because I've checked the whole spring break and there's nothing been posted on there. Has anybody else got their grades posted?
Oh, you know what? I forgot to convert the spreadsheet to export it. Okay, my bad. I'm sorry. I have the spreadsheet all worked out already, but I have not posted the grade yet.
What about
Okay.
the notes for your lectures?
The recording is online. Do you guys think the recording is better, or do you want to have actual
I don't
notes?
personally. I need something visual that that I'm reading and going along with, because you go off track a lot and it's really hard to focus on what's going to be
Understood.
graded, and you know what I mean.
Understood. All right, so I'll work on that part. Having Scratch, you're talking about the Scratch part, right?
No, I'm just talking, you've got different topics up there, but we're like more than halfway through the semester and you've only covered 2 topics that are,
Okay.
we're supposed to go over.
Okay, excuse me. All righty. I will have to work on that. All right. So we were still talking about Scratch, so let's go ahead and finish that topic first. Okay, so Scratch is actually all the way down here to programming logic. It's kind of flow charting, but it's not exactly flow charting. I do not like flow charting at all because even though it seems visual and seems easy to use, it's actually it's not a very good way to capture logic. Okay, if you use flow charting to capture logic and you pass that flow chart to a programmer, it is very possible that the programmer will have a hard time implementing the logic in flow charting. So what we'll do is we'll go back and continue with Scratch and just kind of reinforce the few concepts that we have already talked about. The thing about documenting Scratch is it's very interactive. It's not like Visual Basic where you can just say, okay, this kind of statement behaves this way. This one is a lot more interactive and a lot more visual, so documenting it is going to be a little bit different. All right, so we talked about the 3 control structures that we have talked about. When we look at let's write a new program. Okay, let's just write a new program, and we'll have Scratch to do a few things. Okay, let's make it count from 1 to 5. Okay, that's all we're gonna do. We'll make Scratch print out, counting 1, 2, 3, 4, 5, and then the program terminates. Okay. How should I write this program? Does anyone want to kind of get started here? Go ahead.
You could make a repeat 5 loop and then have a variable that gets +1 every time it's
Okay.
done. Just state the variable.
That's one way to do it. Well, first of all, we have to specify how this script gets triggered. Okay. Scratch, just like with most visual or GUI type programming, is called what we call event-driven. In other words, to start a script running, you have to specify, okay, but how does it get started? Okay. You have all these starting blocks here. How can I tell a block is a starting block instead of a regular block under control? Yep.
It doesn't plug into anything. Or
Right, the top.
Yeah.
There's no way to plug into the top.
Yeah.
Okay. So we are talking about these 3 different types of blocks here. They are all starting points. Whoops. One. This is the same thing. The second one, and then the third one, and then there's 4th one here. Now these are all starting blocks. Okay. The first one, when the green flag is clicked, simply means when you click the green flag over here, then that particular script will start. The second one is when a particular key is pressed. Now you can drop down the box and then you can specify whether you want this particular script to start with an up arrow, down arrow, right arrow, left arrow, space, A to Z, the digits, and that's it. Okay, those are the keys that this particular program can capture. What do you think would be a good use of this kind of starting block when a particular key is pressed? What if you're writing a game? Okay, now that can be helpful because if you're writing a game, you can use these blocks to help you control the character when to perform a jump. When the space bar is pressed, then you can perform the jump motion. This one here says when sprite 1 click. In other words, when you click on the sprite itself, that particular script will start. When do you think that might be helpful? For anything that is interactive. You can turn a sprite into a button, in other words. Okay? So you can basically say, okay, I can design a sprite that looks just like a regular button. Okay? Maybe with even 2 two costumes, one to show you when the button is released and one to show when the button is pressed. Okay, so that's when a sprite is clicked, can be helpful. And the last one, we're not going to talk about is when I receive a particular message. This is helpful when you want to have one sprite to synchronize, some kind of activity with other sprites. It's a little bit way beyond, I would say way beyond the scope of this class, but it does have its usefulness. So we are not going to talk about this one in this class. Are there any questions about the 3 starting blocks in Scratch? No questions? Okay. Most of the time, if you just want a particular program to run, but not interactively, you want to use when the green flag is clicked. Okay, that's the standard one to use. Now we have other blocks here. Now in this case, since I'm counting from 1 to 5, now there are 2 ways to write that program. I can simply use, say, and then say, count 1, count 2, count 3, count 4, count 5. In other words, I can make this program go to looks and just say, say 1 for 2 seconds. I mean, you guys know what I'm talking about. Say 2 for 2 seconds, and so on. Why is this approach not very attractive? If I just want the sprite to say count 1, 2, 3, 4, 5, go ahead.
Too repetitive.
It's repetitive? Mm-hmm.
Save portions.
Right? Go ahead.
You can't change it to do something else.
Mm-hmm. If I wanted to count to 7, I have to change the program. I have to add 2 more lines. If I wanted to count to 5 or to count to 3, I have to remove 2 lines. What if I wanted to count to a certain number that is an input? This approach doesn't work, right? So that's why this is not a very good approach. But I'll do this anyway, and then I'll show you guys, how to make it work with a loop. So I'll just make it go, count, say 1, 2, 3, 4, 5. Oops.
That's quite a jump.
Yeah. And then we'll put an end to it. So we go to control, and then we say stop script here. Now there are 2 stop blocks here. One is stop a particular script. The other one is to stop all the scripts. So the second one, which is the one that I'm pointing at right now, will not only stop this particular script, it will stop the entire program. Okay. Now this is a big difference. Now since we only have 1 script here, stopping 1 single script is going to be okay. So just test it with the green flag. 1, 2, 3, 4, 5, and we are done. Okay. So we don't like this kind of program because it's very repetitive, and it's really hard to make it flexible where we can say, oh, this time I wanted to count to 4, this time I wanted to count to 7, and so on. So we want to turn this into a loop. But to turn this into a loop means that I need something to remember which number I have counted up to at this point. What do we need? What concept do we need to keep track of something that I need for the program to execute? A variable. Very good. So we go to the variable tab here, which normally starts with nothing. Okay? So when you first start a Scratch program, there are no variables whatsoever. There are 2 types of variables. One is called simply called a variable, which means you can only use it to store a particular value. The other one is called a list, which means, as the name implies, you can store multiple items in a list. Okay, that can be helpful in some programs, but in this case, I just need a simple variable. With any type of variable, you need to give it a name, because this is the only way your program can refer to a particular variable and not the other variables. And I would name the variables, depending on what it does. So in this case, it is a count. Okay? You can make a variable available to all sprites if you have multiple sprites, or you can make it available only for a single sprite. The difference between making it available to all the sprites versus one is if you make it available only to one sprite, the same name can be used again for another variable that is only visible to another sprite. Okay? So if count is a very common name that you want to use for different sprites, you want to make it for this sprite only. The only time you want to consider a variable for all sprites is when you need it for communication between the sprites. So for the most part, we just use for this sprite only unless you have a specific need for all sprites. As soon as you click OK, the variable tab shows up multiple items. The first one is something they can drag into a space, like saying. The second one, set count to a particular value, means you can change the value of a particular variable. The third one is change count by a certain number. It can be implemented using the second one combined with an operator, but this is just a handy way to make it increase or decrease by a certain amount. Show variable count and hide variable count simply means you can interactively in your program control whether you can actually see the value of a variable or not. So right now it is visible. If you click hide, then it's not visible anymore. If you ask it to show again, it is once again available. So this can be helpful because what you can do is you can use one variable to keep track of the score of a game. So on the title screen, when you show the title screen of the game, where you don't want to show the actual score because there's no score at that point, you can hide it. But when you're playing the actual game, then you can ask Scratch to show the score. So this way, it will be shown on the stage. Okay. Are there any questions at this point about variables? Yep, go ahead.
Like last time when you were doing when you had the counter, like when it popped up on there, like can you have those like not shown but still like when you input stuff?
Yes.
Okay.
This only controls whether it is shown on the stage, but the variable is actually kind of behind the scenes. So what you're really controlling here using show or hide is simply to say, can I see the value of the variable? It doesn't really change anything else. Okay, very good. All right, so what we'll do now is to use count instead of a certain number. I'm just going to use count here. And I'll probably change the wait amount to just 1 second because this is just taking too long. All right. So let's see what this program will do. It keeps saying 0. Why does it keep saying 0? Why does it do that?
You haven't inputted any numbers for it to count.
That's correct, but I'm also saying the same count every single line. Without any other statements, the value of a variable stays exactly the same, and that's why it's printing, or it's saying the same value 5 times. What do you think I need in order for this program to count from 1 to 5? What do I need between two say count in between? Change by 1, exactly. So I can use change by 1. This is one way to specify that I want to increment the value by 1 between the first and the second say. But I can also do something else. Okay, well, since it counted this as a double click, and that's why it started executing the program. But there's the other way to do it is to kind of a little bit longer. You can set count to and then use operators and then use the addition symbol to drag it over here. And then you can specify count plus 1 on this side. So this will do exactly the same thing. Can everybody see how change count by 1 is doing exactly the same thing as set count to count plus 1? Okay. So 2 different ways to do exactly the same thing. So let's go ahead and test the program just to make sure that it does do what it's supposed to. 1, 2, 3, and then it prints three times because there are no increments here. Okay, let's try that again. 3, 4, 5, 5, 5. It's not counting from 1 anymore. How do I fix that problem? Go ahead.
At the end, set count to 0.
Maybe at the beginning I set count to 1 if I wanted to count from 1 all the time. This is called initialization. In other words, before the script executes, whatever the state of a variable is maintained. Okay, it's going to reuse the same value of a variable since the last time the program terminates. So you don't want to just say, oh, we'll just start with whatever value count has. You want to make sure that count starts with a particular value. So that means you have to use the set statement to set the count to a particular value. Now this part depends on whether you want to count from 0 to 4 or 1 to 5. Okay, because if you want to count from 1 to 5, then you want to set count to 1. So this way it always starts with a 1. Do we have any questions at this point about these particular statements? No questions? All right. If there are no questions, I'll fix this program entirely. So it will do exactly what we originally said I wanted to make this program do. So that simply means I'm going to put the change here, replicate it a few times, put it between all the say statements. And just one more time, put this one back in place, reattach. And this time the program counts from 1 to 5, just like what we said. Right. Are there any questions at this point? Now before we did this, each individual say statement is a little bit different from the one before or after. Because we have say 1 for 2 seconds, say 2 for 2 seconds, say 3 for 3 seconds. They're all slightly different. Do we have identical statements now? I think we do. If you take a look at this portion here, just this portion, it is the same. I just replicated that 4 times or 5 times. So this means we can now use which construct to make it count from 1 to 5. Instead of replicating this block 5 times, since they are now identical, what construct can I use to say, oh, we don't want to keep saying the same thing 5 times. We can use a different construct to simply say, repeat this a certain number of times.
Looping.
Looping, very good. So you go to control here, and then with loops, there are different types of loops. So what I'll do is I'm going to remove this part here because I don't need that anymore, because I just need to kind of repeat this portion a few times. There are several ways to do this. Okay, I'll just go ahead and point out all the loops. One is called forever. One is called repeat a certain count. One is called forever if. And there's one for repeat until. Okay, so these are all the blocks that can go back. What is common within all these blocks that are missing from the other blocks? Visually, they have one little cue to tell you that these are all loops.
A little arrow.
A little arrow. Yep. There's a little arrow here. Okay, see this little arrow here is pointing back up, an arrow pointing back up, an arrow pointing back up, and an arrow pointing back up. These are all little visual cues to tell you that after you perform whatever is inside the block, there's a possibility to go back to the beginning and then do the entire thing all over again. So the question now is, what are the differences between these? So we'll pair these two guys up together and then pair these two guys up because they are kind of similar but not exactly the same. This one is pretty easy to describe. What do you think this one does?
Keeps going.
It keeps going, exactly. Okay, so if I make this our program, okay, so I put this forever block around the statement that we already have, and you can also see that with a forever block, there's nothing you can specify after it. Why do you think that is the case?
Forever's a long time.
Exactly. It's like diamond. Some of you remember that commercial. Well, it is forever. Okay, so if I run this program the way it is specified now, it will count from 1, 2, 3, 4, and it will keep going. Okay, it doesn't stop at all until you hit the stop button. So there is one way to stop this program. If another script, either run by the same sprite or a different sprite, or even the stage, specifies stop all, which is using this block here, it will still stop this script even though it is saying it is forever. If you click this, you can see that now the other script has stopped. So this means that you can have an infinite loop. Okay, a forever loop is also called an infinite loop because it doesn't stop. This means that even if you have an infinite loop, you can still make it stop. It's just that you cannot specify anything after the loop. Okay, there's nothing you can do after the loop. Yep, go ahead.
If you say nothing, does that include creating a new script?
Say again?
Okay, you said there's nothing you can do after the loop.
Correct, because it doesn't give you a connector to specify any more logic after the loop.
But you can create a new script after that.
You can create what we call parallel scripts, but not scripts after that. The placement of the script on the screen has no bearing of how it executes. In other words, I can put this one all the way down here, and it will still execute basically the same way. Okay. But in this context, this is not what I want. So what I'll do is I will take this one away because that's not what I want. What about this forever if statement? What do you think it does? It also has no connector to any logic after that. Yep, go ahead.
The same thing, except it's also putting a statement in it, so it does have a way to end.
All right, so we think there's a way to end this program,
Oh wait.
which means
I think it starts to get into the forever loop when something is clicked or something happens.
okay. Well, let's give it a try then. Okay, so let's go ahead and put this block here, and then reattach this, and then run this program. It doesn't do anything. Now, it doesn't seem to be doing anything, but I know it is doing something because what is one cue that I can see visually to tell that this particular script is still executing, even though there's nothing happening on the screen? Do you see the white line around the whole thing? It's highlighted. That tells me that this particular script is active. So this means that you can have scripts that are active and scripts that are inactive within the entire program. And this is one way you can visually tell which one is still active. This one is still active. In other words, it is stuck in an infinite loop. It's just that because the condition that we specify here is empty, which is the same as false, okay? And that's why whatever you specify inside the block doesn't get executed, okay? So how do I fix this program? In fact, this is one way to kind of fix this program so it will count from 1 to 5. Let's go to operators and see if we can find something that can be helpful to put into the hexagon here. What if I specify the less than comparison, and in here I use count on one side, and then the other side I say as long as count is less than 6, I want this loop, or I want whatever is inside the loop to execute. 1, 2, 3, 4, 5, and then it stops. Okay, it stops saying anything. Has the program terminated? No, the program is still active. It's simply because it doesn't seem to be doing anything because the condition count is less than 6 is no longer true, and as a result, whatever is specified in the loop doesn't get executed anymore. But the loop is still going. Okay? Is the value of count increasing at this point? Is it changing at this point? It is stuck at a value of, no. It's stuck at 6, okay? And that's because 6 is less than 6 is false, and that's why we don't get into the loop at all, and we don't have a chance to increase it any further. Okay? So this seems to do what we wanted to do, but not quite exactly what, how we want to do it. Because we want this program to terminate. We want this script to terminate when we count up to 5. 1, 2, 3, 4, 5, and I want it to stop. Okay, well, so we're getting closer. We're getting closer to what we want to do, but this is not really fitting what we want to do. This block has to do it, right? repeat 5 times. Each time we'll say the value of the counter, and then we can attach a stop script at the end. So this should do it, right? 5 times, 1, 2, 3, 4, 5, it should be done. So let's go ahead and click it. 1, 2, 3, 4, 5, and stop. You can see the highlight around this script is gone, which means this script is done. I mean, it got all the way to stop script, and it stops. So that's what we want to do. But I can tell you this is not always the best way of doing things. Okay, this is kind of like a shorthand. Okay, it's a shorthand because we are simply saying do whatever is inside exactly 5 times. Since I already have a counter, I have another way to do this. Okay, so I'm going to take this one out, extract the content, remove this one out, and this time I'll use a much more general loop like this one. Repeat until. Okay. Repeat until is the most general and the most useful kind of loop in just about any type of programming. This is the kind of loop that you can find in Visual Basic, in C, C++, PHP, Java, Perl, and so on and so forth. It's the most general kind of loop. It basically says, as long as, okay, if you don't want to say, if you don't like the words repeat until, you can basically replace that with as long as. So in this case, I'm specifying a condition. As long as the condition is still true, perform this again and again and again. Okay? So what do I specify here for the hexagon? What is the condition that I want to use to stay in the loop? Yep.
Want the counter to equal to 5.
We want the count to include 5, right? When it is 5, I still want to perform one last iteration. Go ahead.
If you want to make it so that you can count to any number, you want to put an operator in there with the variable +1.
Okay.
So that it repeats plus the 5.
Okay, we can do that. But for now, we'll just say, as long as count is less than 6, we want to perform this loop. Okay. So let's see if this is working or not. Oops. And I specify the flip side of the logic, and of course it doesn't work. Why is this not working? The condition I just specified, count is less than 6, is what we call the exit condition. In other words, when this condition is true, when count is less than 6, we get out of the loop. Okay? Isn't that the normal way to use English? You repeat until something is true. So that means, if that condition is true, you get out of the loop. You don't have to do the repetitive action again. So in this case, I'm saying repeat until count is less than 6. But what is the initial value of count right before the loop? It's 1. Is 1 less than 6? Yes. So the exit condition is true to begin with. That means I don't have a chance to execute whatever is in the loop. So what is the laziest way to fix this program? So I can just change the program so it will count to 5 and then exit. No, that won't fix it. Yep.
Count greater.
Swap the sign.
Swap the sign, yep, until count is greater than 6. Okay, that's one way to get out of the loop. But I can also do something even lazier. Okay, you go to operator here, operators, you go to the not, and I just put a not around the entire thing. Let's see if I can do that. No, doesn't have an easy way for me to do this. In other words, I'm negating this condition here. As long as count is not less than 6, stay in the loop. Okay? Repeat until, oh, I take it back, sorry. It's not as long as, repeat until is repeat until, as long as it's a while loop. I take it back because I was confusing myself. Okay, so this one is basically saying repeat until count is not less than 6, which means count is greater than or equal to 6. Okay, that would be my exit condition. So let's go ahead and test it again. 1, 2, 3, 4, 5, and out it goes. Okay. In other words, we can use repeat until to do exactly the same thing as a repeat count. Okay. So let's take a look at these two loops two types of loops again, and we'll just give you a final analysis. One can implement what the other one can, but not vice versa. Which one do you think is more general? A repeat count or a repeat until? A repeat until is the more general one, which means a lot of programming languages do not give you a repeat count. So this one is missing in many actual programming languages, but almost every single programming language implements repeat until, or something that is similar to repeat until. So that's why, if we can, we want to get rid of repeat count, because it's not a very common construct in a normal programming language. Do we have any questions at this point about this program? Just counting from 1 to 5 and then stop the program. Go ahead.
I get the same result if you set the counter to 0 and then repeat until the counter equals 6.
Yep, that will do the same thing. There are different ways to get to the same result. It's just that if you say it's equal to 6, if you set your initial value to 7, then your loop will never exit. Because if it's 7, 7 does not equal to 6, and you keep adding 1 to it, it will never be 6. Does it make any sense? Okay. All right. So do we have any questions about the constructs that we have talked about so far? Okay. It's a reinforcement of something that we talked about before the break. There's only one more construct that we have talked about already before the break, but it is not in this program. What if I want this to only print or save numbers that are even? Instead of making this program, say 1, 2, 3, 4, 5, I only want it to say 2, 4. There are several ways to do it. I can change the loop itself, but what I can also do is to use a conditional statement. If you go to control here, there are two statements that are conditional statements. One is if, one is if else. Okay, so I'm taking this one away because it is no longer the topic that we are talking about. The first one, the one on the left-hand side, which is also the one that my mouse pointer is over, is if a certain condition executes whatever is inside. That means whatever you put inside this conditional statement here executes if and only if whatever you specify in the hexagon is true. So in a way, it looks like a loop because it has a little condition, but it is not a loop because it is not repetitive. You can see that in the repeat until, there is a little arrow pointing up, but with a conditional statement, there's no arrow pointing up, which means it is only evaluated once to determine whether it's whatever you specify inside should execute or not, and then once it's done, it is done. Okay, it doesn't go back to the beginning. The other one is if else. Okay, it is basically the more general form of the first one. It means if the condition is false, it will go to the else portion. It keeps the same behavior of when the condition is true, it executes the first part. But it will only execute one part or the other. It doesn't execute both parts at the same time or in sequence. Are we still doing okay so far with this? Let's make this program more fancy. I want to make it say whether a particular number is odd or even. So it will first say 1 and then say is odd, and then 2 is even, 3 is odd, 4 is even, 5 is odd. Okay, that's how I want this program to work. Okay. Now, first of all, we have a problem of how do we know a number is odd or even? If you go to operators, do you see something here that can be helpful to determine whether a number is odd or even? How do you know whether a number is odd or even? Yep.
Divide by 2.
Is it wholly divisible by 2? Okay. Which also means when you divide a number by 2, whether the remainder is 0 or 1. 0 or non-zero. Okay. All right. So do you see anything here that might be helpful for us to determine the remainder of a division? We talked about this already before the break, but I know most of you cannot remember that one because it doesn't say remainder at all. Okay, look at all of these operators. Now we know that in order to get a remainder of a division, we need 2 slots, okay? So that rules out round, and it rules out this particular one because it only operates on a single number. This is addition, has nothing to do with division, right? Subtraction has nothing to do with division. Multiplication has nothing to do with division. This one is just division. Maybe it has something to do with what we want, okay, getting the remainder out of a division. So we keep this one around. Pick random 1 to 10 doesn't seem to have anything to do with division. Comparison, 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 nothing about division. Conjunction, disjunction, negation, not a division at all. Join, doesn't say anything about division. Letter, nope, nope, nope. How about this one, mod? That's our operator, okay? Mod is the short form or the abbreviation of modulus. It's basically the remainder of a division. So you specify a number on the left-hand side to be divided by another number on the right-hand side. In other words, this part here, the left-hand side is the dividend, and what you specify on the right-hand side is the divisor. But instead of giving you the quotient, it's going to give you the remainder of the division. And that's exactly what we want. Okay. So we want this to be either of 0 or 1, or 0 or non-zero. So we still need a comparison to say whether it is 0 or not. Okay. And on one side, we need the remainder of something. All right. So can someone help me specify what I should put on the left-hand side of mod? What is our dividend? Count itself. Very good. So we go to count and put it on the left-hand side. And since we are only interested in whether a number is odd or even, what should I specify as the divisor? Divided by 2. Very good. So this time it's just a constant 2. And what are we comparing that to? 1 or 0. Okay, we'll put 0 here. All right. Now if the remainder of the division of a number by 2 is 0, is that number odd or even? It is. It's even, exactly. Okay, if you divide a number by 2 and the remainder is 0, that number is even. All right, so we'll just go ahead and go to looks here. We'll make this program simple for now. Instead, so we'll just go ahead and say even for 1 second. I accidentally triggered the execution of this block and says even because 6 divided by 2 has a remainder of 0. Well, that makes it kind of easy to specify the other one, because if it is not even, it has to be odd. There we go. Okay. So now we can take this entire block and put it inside the construct. So we'll put it right after say count for 1 second. So this way it will say 1 for 1 second, and then next it will say is odd or just odd. Okay, let's make it a little bit better here. So we'll put it is and it is here. Okay, so this way it reads a little bit more normal. All right, so let's try out this program. 1 is odd, 2 is even, 3 is odd, 4 is even, 5 is odd, and that terminates the program. All right. Yep, go ahead.
What does it say? It says count by the if else.
Which part for the program again?
Yeah, and then.
You mean, are you talking about the condition of the loop? This part here?
No, like on the if one, the count right there.
The count mod 2. In operators, is the third last item.
This one.
Okay, are we still doing okay so far with this program? Okay. Have we done anything about syntax in this class with programming? What is the syntax of programming? if you look at the word in the dictionary, on syntax, what do you think it is going to be? How do you think it's going to be described? Hmm? It's grammar, exactly. It's grammar, but specifically for programming languages. Okay. In other words, where do you put a semicolon? Okay. Can you use round parentheses or can you use square brackets? Where can you put a space? What kind of characters can go into a name of a variable? Those are all a part of the syntax of a programming language. In this case, have we specified anything about syntax in this program? No, there's nothing. Okay, so that means with Scratch, it is easier in terms of programming because you don't have to learn all those rules about what can go here and what cannot go here because it's all about the connectors. Yep.
It's only if you look at the DB file code.
Sorry?
It's only if you look at the DB file code for see the syntax.
Right. But in the visual, front end, you cannot see the syntax. Right. You can turn any programming language into something that looks like this, where it is drag and drop, and you cannot drop something that it does not belong. But this is a good way to get into programming for people who have no prior experience of programming. This is a quick and easy way to get into it, because you can focus on the concept and not really get distracted that much by the syntax of a programming language. Are we still doing okay so far at this point? I want to make one more modification to this program. I wanted to say on the same sentence, one is odd, two is even, and so on. In other words, I don't want it to split up the sentence into two different portions. If I run this program again, you can see it is saying one is odd, two is even, but it is split up into two different parts. I wanted to combine one is odd into one single sentence. Okay? So do you think we can do that? Well, if I cannot do it, I won't say it, right? The question now is, how do we do that? How can we combine several things into one single say so that one part of what we are saying is determined by a variable and then the other part is just literal? Yep.
Is it drawing? Is it the drawing command?
No, not the drawing pen. Oh, did you say drawing pen or join? Join, you're right. You're absolutely right. The join operator here will basically combine two things into one when it is time to print it out or put it into a variable. If you just click here, join hello world, it gives you hello world. Hello space world combined into one single thing. So this is what we need. And what we'll do is we'll drag two things out here. And we'll put one into here, and we'll put one into here. We want to say, one is odd, two is even. So that means of the two things that we want to combine, one part is just the variable count itself. So we can drag count into here, and drag count into here. The second part, on the other hand, is the words is this one is even, and then here is space is odd. And this is how we can combine several items, one determined by, or two items in this case. One is basically a variable which changes over time, and then the other part is really just a literal string, which means it is just spelled out and doesn't change over time. So now we'll test this program again. Okay, I forgot to take out the other one. But it does work, okay? 3 is odd, 4 is even, and 5 is odd. The only reason why it's saying the extra thing is because I forgot to kind of take out this piece here. This is the one part that makes visual programming a little bit harder because I can't easily take out one single statement. There we go. So now this entire program is done. We'll give it another try. 1 is odd, 2 is even, 3 is odd, 4 is even, 5 is odd. All done. All right. So are there any questions at this point about what this program does or how it does it? Yep, go ahead.
I'm just wondering, how are we going to be tested on this? Are we going to make our own program at home and see it online?
For homework assignment, that's definitely what you will be doing. I'll give you a programming task to write a script to do a certain thing. For testing, it's a little bit harder. What I can do, in a test is I can show the code, and then I will give you multiple choices. Like, what do you think? Which one describes the behavior of this program? So I can, so you can basically look at the code and you go, okay, is this program going to do blah 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 or blah 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 or blah blah blah? So I think that would be one way I can test it on a paper test. Last time I taught this class, I was able to use the lab for exams. So people were actually writing their code, during the exam. It didn't work out too well because a lot of people cannot work on programming under pressure. The thing about, okay, this is different from an English writing class. How many people have taken or is currently taking an English writing class? In your assessment exams, do you have to write like short essays, during the exam? No.
Short paragraphs.
Short paragraphs. Okay. Yes. Okay. So you do have to write something during an exam for assessment purposes. So why do you think that's okay, but writing a program, during assessment is not nearly as easy? What if you make a little mistake in your paragraph that you have to write in an English writing class in an exam? You misspell something.
That's easily fixed.
Easily fixed, but do you think you will lose all the points?
No.
No.
You would lose all the points.
You will lose some points, right? If you forget, if you misuse a punctuation, do you lose all the points?
No.
And that's because the professor can, for the most part, still understand what you're writing. The concept behind your writing is still okay. What do you think happens when you make a mistake in a program?
The program just stops.
Most likely the program does not work, right? And that's why it is a lot harder when it comes to programming during an assessment, because if the program doesn't work, then how am I going to grade it? Because the program either works or not. Okay, there's nothing in between. So that's why I don't want to give you guys a programming test during the exam. I will give you the code, and you have to select one of the options to describe what the program does. Okay. It can also take on another form. I can ask you about what is the output of the program. Okay. So in this case, I will say, what do you think the program will say about the number, 37? Okay. And in this case, you have to say, but it won't say anything about 37 because the loop doesn't get up to 37. Okay. So are there any other questions about this particular program? Nothing? This is okay? All right. Let me just save it because I think this program can be useful for some people. So I'll just save it. Count 1 to 5. All right. So now let's go ahead and start with the new program, because we want to do as many practices as possible. Let's write a program to find a prime factor of a number. Okay. Do you guys still remember factoring? Okay. How do you do factoring? If I give you a particular number, how do you find at least one of its prime components?
Divide it.
Divide it? Okay, very good. And you keep doing that until
each number is prime?
Well, the number itself may be prime, but it may not be prime, okay? So how do you know whether a number is a prime factor of a number?
Can't divide it anymore.
Can't divide anymore. How about when you divide a number and the remainder is 0, then it's a factor of that number, right? Like 49, okay? 49 divided by 2 has a non-zero remainder. 49 divided by 3 has a non-zero remainder. And 49 divided by 4, 5, 6, they all have non-zero remainders. 49 divided by 7 has a remainder of 0, okay? So 7 is a prime factor of 49, okay? So this is what we'll do, okay? So we're gonna write a program to do just that, okay? So let's go ahead and get started with, just for once, we're gonna do something a little differently, okay? When sprite 1 is clicked. Just so that, we start this program in a different way. All right. And in this kind of program, you don't want to hard code it, like which number do we want to factor? So we probably want to use, the ask ability to say, give me a number to factor. Give me a number to factor. And it's always a good idea to use a variable to store the problem that you're trying to solve. So in this case, the problem we are trying to solve is a number to factor. In this case, I can use this as the name of a variable, a number to factor, because this really spells out what this variable is useful for, okay? And in my other classes, I just call it n, but in this class, I'm going to give it a much longer name. So right after I ask the question, I'm going to set the number to factor to whatever answer is corresponding to the question. So this way, I have a variable called number to factor to store the number that I'm factoring. Okay. Are we still doing okay so far? This part is just for setting it up. Yep, go ahead. You mean here?
Yeah.
That means, sorry. Because you can show it on the screen just like with a normal variable, but you can also hide it so it doesn't show up. Okay. All right. So what we're gonna do next is to say, okay, but how do we find out what is the smallest factor of a number? Where do we start? Do we start with 1? No, because every number is wholly divisible by 1. So 1 is not a good number to start with. Which number should I start with? 2, okay? Now, would that number change? Because first I would test 2, then I would test what? 3. Okay, so it seems like we need another, what? I need something to keep track of the factor that I will be using, that I will be trying. So what do we need here? Another variable. Very good. Okay. So variables are very useful because they can keep track of things that your program needs to keep track of. So we'll make another variable. In this case, I will call this potential factor, because it may not be a factor, it's just potentially a factor. Okay. So here we have another factor, another variable. And we'll set this one to a value of 2 to begin with. All right. So now you look at the logic of this code here, and you think, what are we going to do with this? Well, first of all, we'll try to divide it by 2, see if the remainder is a 0 or not. If it is non-zero, we move on to 3, and then divide it again, see whether the remainder is a 0 or not, and we'll keep doing this. What construct do you think matches what I just described? We'll keep doing this. Do you think it's a conditional statement where you just go in, determine which way to go, and then you merge the 2 paths and then you exit? Or do you think it's more repetitive in nature?
It's a loop.
It's a loop. Very good. Okay. So once we have identified that we need a loop, then we have to pull the 4 options out. Okay. So we have this, and this one here. So we have 4 loops. Which loop do you think will fit our need best in this case? Sorry?
Repeat until.
Repeat until, exactly. Because I can find my factor eventually, so I don't want this to be an infinite loop of any kind. So that means this one and this one are gone. I don't know exactly how many times I have to go through this loop because it depends, right? If I start with a huge prime number, it will have to go through a lot of iterations. If I start with 7, it will only go through a few iterations. So since I cannot predetermine how many times I have to go through this loop, this one is out too, and this is the only remaining choice. Okay. When do I get out? How do I know I have found a factor, or the potential factor is in fact a factor? How do I confirm that? something is 0, okay? So as soon as you identify something is 0, you go to operators, and then you drag the equal symbol, and you say, okay, as soon as something is 0, I'm getting out of this loop. Okay? But what do you think is going to be a 0? Which other operator do we need here to say that, oh, you know what? When this is 0, I know this number is a factor of that number. We have just used this operator in the previous program to determine whether a number is prime, even or odd. Which operator are we talking about? The mod operator, right? So we'll drag the mod operator into the other side of the comparison. And now we have to determine what do we use as the dividend. You go to variables, this will give you two choices. Which one do you think is our dividend? Number to factor is our dividend, which makes the other one our divisor. All right. Here. All right, this program is getting a little bit long. It's harder to see now. So let me see if I can maximize the area here. Go ahead.
You need to change your second set too.
My second set.
Yeah.
Oh, right.
Default.
Change potential factor to 2. Thank you. All right. If the number to factor divided by the potential factor gives me a remainder of non-zero, what do you think I should do? In other words, let's say I have 7 as my number to factor and 2 currently as my potential factor. 7 divided by 2 has a remainder of 1, which is non-zero. So what should I do next? I want to try 3, right? If 2 is not a factor of 7, maybe 3 is. So what can I do to bump up the value by 1? Change blah, blah, blah by 1, right? So I'm going to, in this case, I would change the potential factor by 1. Just bump it up by 1. But that's not very smart. This is all very dumb because this means we're going to try 2, 3, and then we'll try 4, right? And then we'll try 5, and then we'll try 6. Is there anything wrong with trying 4 and 6? In other words, is it possible for me to misidentify 4 is a factor of 7 or 6 is a factor of 7? It won't. Okay, it cannot, because what is 4? 4 is 2 times 2, right? If 7 mod 2 is non-zero, that makes 7 mod 4 non-zero automatically. So this means, even though it's not really the smartest thing to do, it's not going to mess up the program. Okay, I cannot misidentify a number as a factor of another number. It's just that it has to go through some extra iterations that I normally do not want to go through, but it won't, make the program behave incorrectly. It just takes longer. I have to do this because I don't have a list of prime numbers. Now, since I don't have a list of prime numbers, I cannot just test the prime numbers. I have to test all the numbers sequentially. All right. So when this loop exits, that means I have found a factor. The potential factor is in fact a factor. So that means I can go to loops again and use say to specify outside of the loop to say that a number is a factor of another number. Okay. So we know that we have to combine variables again with just literal constant or literal string, literal text, because we want to say blah 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 is a factor of blah blah blah. So how many joins do I need in this case? I got 3 things to do, so we have 2 joins. Okay. When you have 3 things in as components, you need 2 joins. So we'll drag join into here, and then drag another join into either part. It doesn't matter which one. So we'll put it into here. And the first one is going to be the variable potential factor. And then the second one is the number to factor. And then in between, we'll just say space is a factor of, and then space again. And that's it. Okay, we'll go to the end. We'll stop the script at this point. So this is our script to find a factor given another number. Let's see if it works. How many people can kind of mentally or on a piece of paper track this program to see what it's going to do? Okay, one person has the hand up, but I think most of you can kind of do that step by step. Just kind of pretend that you are the script engine and track down this program, either line by line or statement by statement, to find out what it is going to do. This is a little bit harder to track because there are no line numbers. In other words, it's really hard to kind of keep track of where I am at this point. All right, so let's go ahead and run this program. I'm going to increase the stage size so we can actually see what it's asking. Oh, that won't work because I have to click Scratch to start the program, see? So this time it's clicking Scratch, to get the program started. Give me a number to factor. You guys can pick. You can pick something hard.
437.
Sorry?
437.
437. 437. And according to all the rules that we know, we don't know we cannot quickly determine whether this number is prime or not, because we only have quick tricks for divisible by 2, divisible by 3, divisible by 5, and to a certain extent divisible by 11. Do you guys know any tricks that I don't? So, sorry? 13. But 13 is a composite number. It's divisible. It's 3 and 5. Okay, so those are all the quick tricks that we know. So let's pick, this one doesn't fit into that pattern. And we'll just go get it started, and it finds that 19 is a factor of 437. Can someone pick a really big, huge prime number?
1026.
1026 is not a prime number. It's divisible by 2. That's way too easy. Well, we'll give it a try anyway. Okay, give it a try. Click Scratch, and give it 126. And 2 is a factor of 126. Okay, so that one is not very hard. Okay, what else?
371. 371.
371. Okay, let's do it. 371. That was too quick. Sorry?
1337.
137?
Yeah. Or 1337.
Okay. Go ahead.
303.
303. 303 is divisible by 3. So this one's going to be a quick one too.
About 2041.
Say again?
2041.
2041.
41.
Like that? That's a good one to try. And it's pretty quick. As you can see, finding a prime number is not as easy as it seems. Okay? The ones that we can memorize are pretty easy, but once you get beyond, let's say 100, it's actually not that easy to find a prime number. 101 is a prime number. Okay? So let's give it a try and see if it will. Okay. Before you even try this, what do you think will happen if 101 is a prime number? What do you think is going to be the output of this program? 101 is a factor of 101 because a prime number has itself as a factor. Okay. So let's go ahead and run this program with 101. And it will test all the way to 101 to find that 101 is a factor of 101. Okay, well that's working. Next, I want to make this program more fancy. I wanted to find all the factors of a number. In other words, if you give it 16, it will say 16 is 2 times 2 times 2 times 2. If you give it 63, it will say that 63 is 3 times 3 times 7. Okay? It's factorization. Why do we do factorization? When do you do factorization? Why do you need to do that?
To simplify.
Sorry?
To simplify.
To simplify what? Fractions. Very good. Okay, very good. Okay, so this is really useful. Okay, factorization is very useful because you can find the least common multiple and also the greatest common factor between two numbers, which means you can work with fractions a lot more efficiently once you can do this. All right. Okay. If I want to find all the factors of a number, one part of this program I can always reuse, which is this part here. Okay, let me just change the size. Okay, this part here is really just the code or the program to find a particular factor given a number. But if I wanted to find all the factors of a number, I have to kind of keep updating the number. In other words, I will start with a large number, but every time I find a factor, I will want to divide that number, the original number, by the factor, and then whatever is the quotient, I will work on this again until it is 1. Is that making any sense? In other words, if I use the whiteboard, or I can just use my text editor here to describe the logic. Okay, if I start with, once again, let's start with 63. So the first factor I will find is 3, and I will say, oh, 63 is 3 times 21. So the 3 here is already taken care of. What I need to deal with now is the 21. 21 itself is 3 times 7. So this takes care of the 3, but at this point, even though we know that 7 is a prime number, the program has not identified that 7 is a prime number. So in the very last one, it will say that 7 is 7 times 1, and it will print out the 7 here. And when the number that we want to factor becomes 1, we are done, because 1 is not even a prime number. So this program will print out 3, 3, and 7 as its output. Okay? When you look at how this number got changed from 63 to 21 to 7, and then eventually to 1, what do you think happens within each iteration, within each step? What am I doing to this number, the number to be factored? It is divided by a factor that we have found. Is that making any sense? Okay. And do you think this process is repetitive? And do you think that we can predetermine the number of times we have to repeat this process? There's no way we can predetermine, right? If I give you 65,536 to begin with, how many times do you think this will go through? That's an interesting number because it is 2 to the power of 16, okay? So in that case, if I start with 65,536, it will say 2, 2, 2, 2, 16 times, okay? And that's what we want this program to do, okay? All right. Well, since it is repetitive, and there's no way for me to predetermine how many times I have to go through the repetitions, I have only one choice to specify the loop here. It is a repeat until. Okay, because I can only specify the condition where okay, if this condition is true, we can now get out of the program. The condition to get out is based on, now this part I'm just going to go through a little bit quickly here. We'll get out when the number we're trying to factor becomes a 1. Okay, so we'll go to variables, and then we go number to factor is 1, we're going to get out. Okay, so we'll stick this loop over here. And then within this loop, we want the first thing we want to find is what is a factor of this number. But then we also have to say for something else, or we have to do something else. Remember, within each iteration, we have to divide the number to factor by a factor that we have found in that iteration. So that means in this case, we also have to update the number to factor over here by using division. So the number to factor is going to be divided by a factor that we have found, so that when we go back, the next time it will try to factor a different number. Okay? And this is it. This is done. Okay? This program will find all the factors given a particular number. So we'll give it a try. Like, which number do you want to try? 65,536? Sorry?
419.
419? Okay, we'll try 419 next. 65,536. 2, 2, 2, 2. The important part is, does it exit when it's supposed to? And we're done. All right. I didn't count. Was it 16 times?
Yeah.
All right. So let's try again with 419. Okay. So let's try 419. And that's a prime number. If it's a prime number, it will just print 419 is its own factor, and then it will exit the program. Yep. And then the program should exit. Very good. All right. So are there any questions about this program so far? Did you guys see what I just did? I wrote a simple program just to find a particular factor given a number, and then I put another loop around it to find all the factors given a particular number. Okay. So we'll save this program again, but this time using a different name because I don't want to use the same name to save this program. Oh, you know what? I forgot to save it earlier, so I'll just save this one as factoring. All right. So this is the end of today's class. I will try my best to capture this, on paper because it's very interactive, which makes it a little bit harder to capture on paper.
Tests.
Tests. Yep. Update the test score.